Okay, I guess we can start. Am I audible? You can
Yes, sir,
confirm.
you are.
Yeah, you can come. Yeah, thanks. Uh, is my slide visible to you guys?
Yes,
Can.
sir, it is visible, sir.
Okay, fine. So, hello everyone. Welcome to the second week session of problem solving discussions for the course NOC 22 CE 68 Ground Improvement. The course is currently tutored by Professor Dilip Kumar Bedia, who is currently working as an head and professor in Department of Civil Engineering, IIT Kharagpur. Myself, Rituraj Singh Sujawat, I am working as a Prime Minister's Research Fellow in the Department of Earthquake Engineering in IIT Roorkee. So those who have joined right now in this week, like just want to give a brief overview what we are going to do in these sessions. So basically, this 1 hour session will be consisting of an interactive session with the learners, where we are going to discuss some important concepts which will be required to solve the assignment problems which are there after every week. We will be solving some previous year questions also. There will be doubt solving sessions, like if you are having any doubt regarding the course for the ground improvement, or like regarding the assignment, uh, like related questions to the assignment, we can discuss here. And also if any other technical or non-technical query you are having about the course, we can discuss it here. So basically in today's session we are going to discuss uh, some few questions, like related to the content of the week 2. One second. So yeah, we'll be having few questions regarding the content of the previous week. Like previous week was basically revolving around the uh, compaction technique for the shallow foundation, shallow soil. So how the ground improvement can be done using the compaction method. So we'll be having questions regarding that only in today's session. So I'll be starting the questions. So before that, if anyone is having some query or doubt regarding the session, like they can ask. Fine then, like we'll be starting with the questions. So here is the first question. Like you can give your answers in the chat box, or like. So the first question we are having is, which type of roller among these can be used to compact the coarse grained soil? So we are having four options with us. Like you can select any one of them. Like the correct answer. You can post your answer in the chat box if you want to. Fine then. So the answer of this question is like we'll be having the vibratory roller, which can be used to compact the coarse grain soil. So the basic reason behind that is because the vibration can be used to reduce the air void, and correspondingly it can help us in densification of the granular soil. Also, due to the vibration of the layer, you can see there will be some rearrangement of the particles, and this rearrangement of the particles is basically happening due to the oscillation of the soil particles whenever they are subjected to the vibrations. So just to give a brief idea about like how the compaction is done through the vibration, like here is one video. So here is a roller like which is working upon a pavement, like we are having soil 200. So this vibration roller, you can see like there are vibrations which are basically causing the rearrangement of the particles through the oscillations, and will be having a densification of the soil or any other medium with the help of this vibration roller. So yeah, this was about the first question. Moving to the next question, like you need to select an incorrect statement about the effect of compactions of soil. So among these four, what do you feel which is incorrect? So just give your answer in the chat box. Okay. We need to select incorrect statement. So yeah, if you would have gone through the lectures or notes of the previous week, like this is pretty straightforward. So compaction basically helps in the densification of the soil, so due to which the air void or void ratio between the soil particles will decrease. So will be the incorrect statement among these four will be like it increases the permeability of soil. Like all three other statements are in favor of this effects of compaction of the soil. So we'll see the reason behind that. So basically, with the help of the compaction, there will be decrease in the volume of the soil, and which will expel the air void out of the soil, and that process is basically the compaction. And also, due to the compaction, like after the compaction, the soil particles will basically come close to each other, like, and there will be some interlocking between them due to that densification, and which will basically increase the bearing capacity and the shear strength. And also the reduction of the air voids, uh, due to, like, since there is a reduction in the air voids, we can clearly observe that like there will be uh, decrease in the permeability and the porosity, and like in the answer it was given as the increase in the permeability of the soil, so that's why it was incorrect. And we can see that the C part, like since there will be interlocking, so the particles will come more closer to each other. There will be, they will be having, like they will be in the larger contact as in the previous case when they were not compacted. So the frictional, due to the increase in the contact, the frictional characteristics of the soil will also increase, and definitely due to the densification, the compressibility of the soil will decrease. So also the compaction makes the soil stiff, and therefore the overall settlement of the soil will get reduced. So yeah, that was easy question. Like if you are having have any query regarding it, like you can ask. Also, like if you feel anywhere, like if you are having doubt or if I am going too fast, just unmute your mic and you can ask me to slow down, or like you can ask your doubt regarding that. Fine, then like we can move to the next question. So here is the third question. In compaction test, if the compacting effort is increased, it will result in which among four of these options? Uh, if there will be no change in maximum dry density and decrease in optimum moisture content, OMC here it denotes optimum moisture content. Increase in maximum dry density and OMC, increase in maximum dry density and OMC will remain unchanged, or D option, increase in maximum dry density and there will be decrease in OMC. Yeah, Shashi, any doubt you have? Like you can unmute or you can post your query in the chat box.
No, sir. By miss, I just pressed that. Sorry.
Okay, Shashi. No problem. So yeah, we are having some answers. So basically, due to the compaction, like if we are increasing the compacting effort, means if we are applying the more number of blows to the soil, or due to some way if the mechanical weight due to which we are compacting it used to get increased. So what will happen, due to which we can see in the next slide. So the answer of this question is basically it will increase in maximum dry density and decrease in optimum moisture content. So the reason behind this is because we know that, like, the graph here denotes on the y-axis is moist unit weight, or like basically it's the dry unit weight only, and at the x-axis we are having the moisture content. So as we are going to increase the compacting effect, means the number of blows if you are going to increase, so the graph you can see it will shift to the left. So if at any point if you compare these two graphs in between, like I'll give the point to. So if at any point if I compare two graphs at different moisture content, so we can see that, like, the moisture content, as we are increasing the compacting effort, the moisture content is decreasing and the corresponding unit weight is increasing. So actually, sorry, this is the dry unit weight. So due to which the option D is correct. So there will be increase in the maximum dry density and there will be decrease in the optimum moisture content. So coming, like, any query regarding this question, like this was straightforward, like basics from the soil mechanics. Then also if you are having any query regarding it. Fine, we can move to the next question. So again, this is a database question, so you can answer. So the equipment or any technology which we are using for the compaction, so on what parameters among these three it will depend upon, like whether it will be the soil type, water type, or the particle size distribution, or it will be depending upon all of these three factors. So the answer of this question is, like, it will be depending upon all of these three factors: soil type, water type, or particle size distribution. Because definitely soil will be one of the factor. Like if there will be soft soil or the clay soil, so the compaction effort required would be like the equipment which will be using won't be needing that much heavy weight as we required in the steep soil or the dense soil. And also the water type also depends, because the moisture content in the soil will basically help us in determine, like, how much compaction effort we want to apply on the soil to get the required relative density. And the particle size distribution means among the soil matrix how the different soil particles are distributed if we consider any block of the soil. So it will depend upon that also. So we'll be having all these three factors which will be contributing in determining the performance of the compaction equipment. So any query regarding it, like why it should be depend upon this or why it shouldn't be depend upon this, like, you can ask. we can have a discussion about the things at the elemental level also, like not at the major, like at the, we say, macro level, but at within the soil particles what's happening, so between us we can determine. So yeah, Bhaskar asks how water type is a factor. So like water type is basically, it's denoting the amount of the moisture. So that's what you are asking, like how the water is determining the, is a factor. So yeah, one second. So if we considered any soil type, and if we are having the soil particles distributed among them, please mind my drawing, but yeah, this is the soil we are having. So if we consider, if I take any particular cross section of that, and if I zoom it, so these soil particles will be having some water layer between them, or the presence of water, we can say, here. So definitely the amount of water which is present in these particles, between these particles, will be decreasing their interfacial strength. So here, if there will be water present, so the interfacial strength between the particles will get reduced due to the presence of the water. So the amount of the compacting effort required to compact these soil particles won't be, like, it will be depending upon the water. If the water will be too less, so definitely we won't require that much effort. But if there is, if water is too less, there will be requirement of the densification effort. But if there will be presence of the water, then we need to reduce the compacting effort, like the amount of compaction we are required, or the blow count, or the type of equipment which we are using to compact any particular medium, this type of soil. So that will be reduced with the presence of the water. So like basically the presence of water will increase, will be giving the increase or the decrease in the overall density of the soil. One second. So I guess, like, I had answered your question. Like if you have any doubt, like, you can ask. Bhaskar. Okay, fine. So any other query regarding this, like? Fine, we can move to the next question. Like, now we are having the theoretical questions. So we, like, the next set of questions, like from 5 to 7, it's based on this paragraph only. So the in situ moisture content of a soil at a boro area is 13.5%. So initially at a site, like from where we are extracting the soil, the moisture content at that site is basically 13.5%, and the bulk moist unit weight of that soil is 16.5 kilonewton per meter cube. Specific gravity of that soil solids are 2.70, and the soil which is excavated and transported to a construction site was used in a compacted field. The finished compacted volume is 2000 meter cube. If the specifications call for the soil to be compacted to a dry unit weight of 18.5 kilonewton per meter cube, and the moisture content at that site is 15.5%, so you need to answer next set of questions based on this. So basically like at a particular site, we want to uh, give a compacted volume for any type of field, you can say. So, and for that we are excavating a soil from another site. So at that remote locations, the properties of the soil, for example, the what is the moisture content, what is the unit weight, and the specific gravity of the solids is given at that site, like from where we are excavating. And that soil, when we are bringing to the compacting site, the properties, the characteristics of the soil are given here, and the volume of that compacted part is also given. So first you need to determine like the void ratio of the compacted soil, like the the place where we are giving the fill with the compaction, like what should be the void ratio of that. I guess if you were solving your assignments, you guys would have faced the similar questions in the assignment also. So if you had solved that, then like it's an easy question. Any answer, guys? So these questions you would have solved in your soil mechanics course also, if you had done it earlier. D. Okay. Yeah. So the correct answer is D. It's 43 percentage. Sorry. Yeah. Void ratio 0.43. So I'll solve it for you guys. So this is our, like, you can consider the excavation area, and from there we are bringing it to the compaction site, where we are compacting, and the volume of the soil here is, you can say, 2000 meter cube. And what else was given? The moisture content here is 13.5. The moist unit weight is 16.5 kilonewton per meter cube. Yeah. So the water content here is 13.5. Gamma bulb, you can say, is given as 16.5 kilonewton per meter cube, and the G value is 2.7, volume 2000 meter cube, gamma D is given 18.5, moisture content is 15.5, unit weight, yeah, void ratio of the compacted. So basically we need to calculate for this compacted film what is the void ratio. So since gamma dry is given, so we know from the relation that gamma dry is equals to G gamma W upon 1 plus E. So like basically we need to focus upon E. So if you bring the gamma dry at the bottom and you will calculate the void ratio, so if you put the values in this, for example 2.7 into gamma W, that is 9.81 is given, gamma dry is 18.5 and minus 1, so 2.7 into 9.81 answer divided by 18.5, yeah, so it's 0.43. So the void ratio is 0.343. So the major part in this question was to have knowledge of this relation, like else was like this calculation. So coming to the next question, like you need to calculate the degree of saturation for the same compacted field.
Sir, we did not able to see what you have written. The problem.
Okay, that part, like, is it not visible?
No, now it is visible, sir.
Okay, was it with everyone? Fine, like you can check the calculation here if it's visible now. So it was basically depending upon on this relation only. So we need to calculate the void ratio with the help of this relation. So coming to the next question. Someone is entering in the room. Fine. Moving to the next question. Sixth question is visible to you guys? Okay. So you just need to solve the degree of saturation for same compacted field for which you have calculated the void ratio earlier. The void ratio earlier was 0.43, so with the help of that you can calculate the degree of saturation. So, any answer? Any answer, guys? So, yeah, it's straightforward. The answer is 97%. So, it's basically depending upon the relation upon ES equals to WG only. So you were having everything, WG by E will be the part, and water content was given as 15.5 and G was 22.7. E was 0.43. So I guess the answer, yeah, so it will be near around 97%. Any query in this? Fine. Like the last question of this paragraph is like, now you need to calculate the volume of the soil which we need to excavate from that borrowing area, like from that borrow site, like how much volume of the soil we need to excavate. So these are the options available with us. So it required a bit more calculation, so you guys can take time. That's no problem. Yeah.
எங்கப்பா டேய் வாடா வெளில வெயிட்டிங் having here
I guess 1 second. any lead in this question? Can anyone tell me like what should be the basic formula or concept we should use like before proceeding? Yeah, Joel, we will be doing that, but like before that, if anyone want to give the answer, or someone want to give a brief overview like how we can uh, proceed with the question, like what should be the initial part, or like this should be the basic idea or concept we should use. Anyone?
To weight by volume.
Yes, Shashi, pardon.
Can we use the density equal to bulk density equal to weight by volume? From that, can we get the weight of the soil material required?
Yeah, so you are pretty close, means almost. Yeah, that is the major concept required. So along with that, a bit calculation. So we'll be equating the weight, like because the weight of the soil which we are taking from the borrowing side to the compacting field side. So if we assume that like while transporting the soil there is no loss in between, so we can equate the weight of the soil which we are taking from this borrowing side to the compacting field side. So with the help of that, like we can solve for the volume of the soil. So yeah. So again, like so this is the part we are having. So this is the excavation area we are having. We are transporting the soil to the compacting field. The volume of this soil is given as 2000 meter cube, and we need to determine what is the volume here that should be carried, and gamma d and w, gamma d and w are 18.5 and 15.5. Gamma d here is 18.5 kilonewton per meter cube. W here is 15.5. Moisture content 13.5 and moist. Here moisture content is 13.5. Gamma bulk is given as 16.5, and the G value we are having is 2.7. So the weight of the soil which we are transporting from here to here, so weight of soil at excavation area will be the weight of soil we are taking to the compacting field. So since we are having, first we will calculate how much weight is required at the compacting field. So weight at compacting field site. So we know the volume of the soil gamma dry. So basically first we need to calculate the gamma bulk because that will give us the total weight. So gamma bulk we know is given as gamma d into 1 plus w. Gamma d is 18.5 into 1 plus W.155 we can take, and so this is the gamma bulk we give. So the weight will be uh, unit weight, that is 21.3675 into the volume we are having is 2000. So 42.735 into 10 to power 3 kilonewton we can say. So this weight, now with the help of this weight we are going to calculate the volume. So gamma bulk here it's already given, so volume then will be given as volume at compacting field site will be given as, we are having the weight 42.735 into 10 to power 3. If we are having the 16.5 kilonewton per meter cube, so if we so yeah, we are having something around 2590 meter cube. So the answer 2545. Okay, so yeah, we are nearby the answer. So maybe due to some significant digit problem, like we can have this thing. So yeah, but if the most closest answer, if you can see, it's 2545 volume, like in meter cube of the soil. Any query in this, like regarding the part, the weight of the soil? One second. Was my slide was not visible earlier? Any query in this, like in the calculation or in the concept? Yeah, Bhaskar, something. Okay, like if you are having any doubt regarding something.
Sir, the weight you calculated now is for the compacted ray density, no?
Which one?
Now the weight which you calculated,
Yeah,
it is for the compacted fill.
yeah, this
Is it the same amount of weight we have to bring from the borrow area, because the properties are different there, no? The bulk density is entirely different.
yeah, but the Okay, so you are saying like we need to calculate the dry weight, is it?
Yes, sir. Sir, what I'm understanding is the bulk density of the compacted fill is different,
Mm-hmm.
and the bulk density of the borrow soil is different.
Yeah, yeah.
Now, you are calculating using the bulk density of the compacted fill.
Okay.
How can that be same as that of the borrow area, which has different properties?
So the volume will be different, right?
Yeah, volume will be different, sir.
So, but the compacted fill, so that different characteristics will contribute into the change into the volume.
Okay, sir.
No, if you are having any like suggestion, you can say no problem.
No, sir. What I am the volume required in the borrow area. I mean, the whatever the weight we
Mm-hmm.
I mean volume we bring from the borrow area
Mm-hmm.
should be higher when compared to this 2000. But you calculated using this gamma D of compacted soil. Will that be the same?
So gamma D, gamma for like for the calculation of the weight of the soil at the compacted field, I had taken the gamma D 18.5. Okay,
Yes, sir.
sorry, yeah, this will be the gamma bulk you were saying, right?
Yeah, yeah. Sir,
21.3.
if we use bulk, if
Yeah,
we
yeah, yeah.
use after calculating this
Hmm.
bulk density, if we calculate the weight, we will get whatever you have 2590. But
Hmm.
if we use the same gamma bulk of the borrow area, then it will be different, no?
Gamma bulk. So this gamma bulk is of the Boro area, right? 16.5.
Uh,
16.5. So the at Boro area the gamma bulk is 16.5 only, right?
yes, sir.
So we had used that only 16.5.
Here you have used this 21.36, no, sir?
No, like the weight calculation here, here at the compacted field. This weight of the
Yeah.
soil, like whatever weight we are getting, this much amount of weight will be taking from the excavation area. So from that excavation area, we are going to calculate the volume. The weight of the soil required here will be the same as the weight here. What you are getting answer like?
No, no, I'm not getting. I mean, only the query, that's all, sir.
Yeah.
It
So
is the gamma bulk of the excavation area is different, and gamma bulk of the compacted area is different, no?
yeah. So with that gamma bulk, like first I calculated the volume. So that vol sorry, with that gamma bulk first I calculated the weight at the compacted field site. So that weight of the overall matrix will be the same like which we are bringing from the excavation area. Yeah. So
Okay,
at
sir.
that excavation area the weight is same but the volume of the soil will be different. So that volume of the
Okay,
soil,
okay.
like then I am using the gamma bulk of this 16.5 kilometer per meter cube. And with the help of that
Fine, sir. Fine.
I am calculating the volume at the compacted.
Yeah, if we
Okay.
use gamma B of the excavated area, then volume will be much more higher.
Yeah, one
Is
second.
it so, sir?
Actually, I guess here is the confusion. Uh, this is the excavation area I should write. One second. So yeah, like I just strike it. So it should be the excavation area. I guess now it's fine for you because
Fine, sir.
yeah.
Thank you, sir.
uh,
Fine. Yeah.
sorry regarding that. And So yeah, anyone else is having doubt in this regarding that? So yeah, moving to our next set of questions. So like, what will be the equation for the zero air void line? So among these four options, like you can select one. Like in the when we are having the maximum dry density versus optimum moisture content graph. So in that we are having the zero air void line. So what will be the equation in that? So among these four, like it's a straightforward question. Right? You can answer. Yeah. So it's just an equation only. So yeah, the answer is B, G gamma W upon 1 plus GW. So if you would have solved, like, the zero air void line is given as G gamma W equals to 1 plus E, and from the relation we know that G gamma W ES equals to WG by S. At the zero air void line we are having the fully saturated soil, so S equals to 1, and then we are having G gamma W upon 1 plus WG. So anyone is having doubt in this? Like, fine. Moving to the next question. Again we are having a set of two questions from a same concept. So yeah, if we are having a 1 meter wide square concrete footing which are going to be embedded at depth of 1 meter, and the site is having 8 meter thick soft clay soil from the ground surface underlain by very dense sand, and the groundwater table at depth of 0.5 meter. The unit weight of the soil of the groundwater table is 18 kilonewton per meter cube. Below groundwater table is 20 kilonewton per meter cube. We are having a column load also of 155 kilonewton. The unit weight of concrete is given, like which is used for the foundation. Like then we need to calculate what will be the applied pressure at the base of the footing. So if I draw a figure for you, like this is the ground surface we can consider, 1 meter wide square footing. So this is the this is the 1 meter wide square footing we are having, which is embedded at a depth of 1 meter, and the groundwater table is at depth of 0.5 meter. So this depth is 0.5 meter, and here we are having the water table. The unit weight of the soil above the groundwater table. So the gamma W at the top layer we are having as 18 kilonewton per meter cube, and below groundwater table is gamma W is 20 kilonewton per meter cube. The column load is given, means if this is the footing, the load here is 155 kilonewton, and the unit weight of concrete is given as 24 kilonewton per meter cube. So we need to calculate what is the applied pressure at the base of the footing. So first part is like how much pressure is applied here. Any answer? So I guess we are running short of time. So if anyone is having answer for this question, like they can shoot, or like I can solve it for you. Fine, then so the answer is 174. So we need to find, like due to the applied load, what is the applied pressure at the base of the foundation. So we are having the, like if we consider this part, this portion, uh, pressure at the base. So we are having the load coming, like dead load coming from the top, then we'll be having the, sorry, the applied load, dead load from the footing, applied load from the column. Since we are calculating the pressure, we need to multiply it with the area of footing. Minus, we'll be having the buoyancy pressure from the water also, so that you can say as U. And then so dead load was 155, sorry, applied load was 155, dead load was, if we say 24 kilometer per meter cube, we'll multiply it 1, and the area of footing is 1, minus the applied buoyancy is, so since the total height is 0.5, the ground water table at depth, so the base here, okay, so this length is 1 meter, the overall height. So the applied buoyancy pressure is 0.5 into 10, if we consider the unit weight is 10 kilometer per meter cube. So this is 155 plus 24, 179, minus 5 is equals to 174 kilonewton per meter square. Yeah, so this was the part, and the final question is like you just need to calculate what is the effective overburden pressure at the base of the footing. So it's basically the effective stress at the base of the footing. So any answer for this? It's just one line calculation. So yeah, if we consider, like just need to calculate the effective stress at the base. So sigma dash So the unit weight, so above the groundwater, above we are having the, 18 kilometer per meter cube. So here is 18 into 0.5 plus below the water the unit weight is 20 minus, since the water is there, so there will be pore water pressure, so we'll be reducing the effective weight, and here it's 0.5. So 9 plus, if we assume this is 10, so yeah, they must have assumed the unit weight is 10, so yeah, it's nearly equals to 14 kPa. So that was just an like effective stress calculation at the base. So yeah, this was the final question. Like, so if you are having any query regarding any questions for today's session or like the previous session, like you can ask, or else we can close this session today. Sorry for
Sir, I have one question.
yeah.
Excuse me. Yeah, sir. In the video, one problem was shown. Maybe I think the similar kind.
Okay.
It is a soil. I think soil has the clay soil up to maybe some 5 meter or 6 meter depth. The water table is there up to 0.5 meter from the ground surface. Actually, the existing soil will be replaced with the good soil for about say 1 meter. I think so.
Okay.
Sir has shown calculation regarding the general shear failure at the top and at the top. I think at the top of the filled soil where the footing rests.
Okay.
And how to calculate this punching shear failure of that, and also should we not calculate the stress on the earlier soil maybe after that 1 meter depth? Should we not calculate what is the effective pressure at that level also?
So like I have not like
Sir, I think
I didn't see that question,
yeah.
but like what you are saying, like this is the ground, this is
Yeah.
the 6 meter depth you are having, and at
Yes, sir.
0.5, like this is the clay soil, right?
Yes, sir.
And till at 1.5 meter you are having the groundwater.
Yeah, 0.5 meter groundwater table is there.
And like here at the 1 meter they are trying to
Yes,
excavate the area.
yes, sir.
And this is 1 meter.
Similar to this problem, at 1 meter level, the footing base will be there.
Okay, here the footing base is there.
Yeah, at 1 meter below, footing base is there.
Okay.
Then below that, 1 meter, below that 1 meter, the soil will be excavated. The existing soil will be excavated and filled with say Murram type of soil.
Like 1 more meter you are saying, like at here.
Yes, sir. Yes, sir. Yes, sir. 1 more meter.
Okay. So they are excavating this whole part of the soil, right? Like up
Yes,
to
sir. 2 meters will be excavated.
Okay.
Out of that 1 meter, good soil will be added to this, and the remaining the footing will lie on the replaced soil.
Okay.
Now in that problem, below the footing, they have shown what is the SBC.
Okay.
Is it not required to find below this 2 meter level? Because the earlier soil is soft soil.
Okay.
Yes, sir.
So like in the question did they specify like it's general shear failure, like, or you have to do the calculation through this?
No, sir. No, sir. In the video, they have done using general shear failure.
Okay, and you are asking like it should be checked for the punching shear failure also and like for the local shear failure also.
Punching shear, yes, sir. Punching shear failure also at 1 meter level from the top,
Hmm.
as well as both shear criteria and punching criteria at 2 meter level.
Okay, means here you are saying the general punching and
Yes,
the
yes, sir.
local shear failure should be checked here, right?
Yes, sir. Yes, sir. Should we need to do that, or is it sufficient if we calculate at the top itself, at 1 meter level itself?
Okay. So actually, in general practice, like we need to calculate for all those three criteria, like to see whether they are satisfying the like design criteria or not. But like if I'll check with that question, like with this, like in the next, I'll post it with the like you can post your question in the discussion form also, and like I'll be checking this question again. So, in my opinion, it should be checked with all those three criteria. But
Yeah.
why they have not done,
And
like
in
I'll
the
cross check with
video,
that. Yeah.
yes. And in the video, they have not done calculation for this punching shear failure. If you can help in that also,
Sure, sure,
it will be a good tool.
sure.
Yeah.
I'll check
Actually,
with
for
that. But
in the video, two or three mode of failure is described, but only general shear failure is considered. So, shall we get reference for other modes of failure also calculation?
yeah, in the design practice, we need to consider all those three criteria, punching and that other
Yes,
failure.
but in video only one is considered. So, shall we get reference for other two mode of failure also? How we can calculate it? That
So,
is what sir is asking.
so reference means like the calculation part you are asking, like which whether we should
Yes,
calculate.
yes, yes.
Sure, Tushar and Sashi. Like I'll check with that. So in the upcoming
General
section,
shear we know, but we are not aware of other mode of failures.
yeah, I got it.
So it is better if you can provide us.
Sure, Shashi and Tushar. Like I'll check it. Like if they had done it, maybe it was not required for the other two criteria. Like it was satisfying in the general share only. But if the general share, if they had not checked with that, so I'll get back to you with the calculations like in the next part, next like so problem solving
And
discussion
sir,
session.
one more question, sir.
Yeah.
In real scenario, how do they actually do this type of work, like excavating when there is water table up at 5.5 meter level?
Hmm.
How do they actually replace with the good soil, like in that problem?
So I guess like if the water table is present, so this excavation and replacement methods the engineers generally used to avoid. Like if you would have gone through the slides also, so there they had mentioned like if the water table is present at that depth, so they used to ignore like replacing the soil. So they either used to go with some uh, pumping method or what drainage methods to first drain out the water. So if water table is present at like if we are considering very large area, and in that large area if the water is present, so excavating that whole soil and with the water present, it's not a feasible practice. So excavation and replacement method, it shouldn't be done for those sites. If you would have gone through the slides, if you had seen that, there they had mentioned like where
Yeah,
we can't use.
but for for building foundations, this can be done, no, sir. Maybe in the roadways, road works, I think, as you said, it is not a good practice. But what about in the scenario of buildings?
So again, like if the water is present, so we need to pump out that water, like even before replacing the soil also, if you see. So at a particular depth, we need to pump out the water. Then only like even in the building area, like if you excavate the soil, but in the history there was water, so with that water we can't proceed, right? So I guess like you are understanding what I'm trying to say, right?
Yes, sir. Yes, sir.
Yeah. So in the building area also, if some till some depth of water level is present, so though the area is very less as compared to the pavement or like for the road works, but for laying the foundation, first you need to uh, pump out the water, and then you can carry out with all the calculations. So for certain depth, like we need to pump out the water till, like, not to certain depth, but like how whatever excavation is done, like from that excavation part the water should be pumped out.
Sir, one practical question I have. Actually, recently we were doing footing of, excavation for some building.
Okay.
We encountered a old well, the existing old well, which was just filled up. But now, since the pond, or there was some nearby water body, and because of that there is a huge amount of water present in the well. Now we
Okay.
want to lay the footing in that area. What would be the best measure to take in such situations, sir?
Actually, yeah, means there are ground improvement methods available to that, but like, since if it's an industrial area, like I'm not uh, that technical profession, we can suggest that. So like before saying any answer, like I need to look into the literatures, definitely. But I guess like before doing that, you like the literature, the part which I had gone through, like you need to go for the drainage and the pumping techniques only. So it's just an idea, like I'm not giving a accurate answer. So before doing that, like they used to check the feasibility of the various methods before going on. So but uh, in the usual practice which we have read in the books, like they used to proceed with the drainage activities only, or the pumping water only. And yeah, that is the part. Means, like on those sites, like usually the first of all the construction on those sites used to be avoided, but yeah, it's not feasible to avoid all to avoid the construction always. So in those cases, like if there is too much water level is present, like with the help of the pre-vertical drain, so like some other drainage facilities we are having, we used to remove the water from that part, and then we used to proceed with the methods. So again, I'll like there are various techniques available, but as of as right as of right now, like I'm aware about this only. Like you can post your same question in the discussion form also. So like Professor Dilip may address your query, like he's having a great technical expertise in that. So yeah, he'll address your question in that.
Sure, sir. Thank you, sir.
Okay, thank you, Sashi, for your question. Anyone else is having something? Like if I know something, I'll help you with that, and if I don't know, like I'll be taking your question to the other technical experts, and like I'll be coming with the answers in the next problem solving discussion. Fine, then I guess we can close our session today. Let's meet on next Tuesday again at 6 p.m., and like I'll be coming with another set of questions. So till then, like thank you so much for attending the session today. uh, Goodbye.